Hey, how's it going? We're going to do homework 1 part 1, in which we will calculate the Jacobian of our helical curve and compare it with automatic differentiation of jacks. Alright, so to get the Jacobian, we're going to want to define a couple of functions. The first one we'll call getJack. That's going to take in a function, which is going to end up being our curve function. And then we're going to need to define our inner function. I'll call that Jacobian. And this one's going to take in x values and h, which we're going to want our h to be essentially 0. So make it a really small number. And like I said, it's going to take in x, but we want these values to be at least an array. So np.atleast 1b accomplishes this. And then we're going to want to create the values of the function as well. At least 1d. And that's going to be the function at these values. And then we want to create our Jacobian array, and that's just going to be, for now, zeros. And we're going to edit that. And we want it to be the size of the two arrays we just made. Alright, and now we're going to want, like I said, we're going to want to run through our Jacobian array. And actually calculate the Jacobian. So for I in range of x dot size, we're going to want to create our x plus h term. So we'll do x is equal to x0 dot copy, and then through each term we want to add h to it. And now we want to go actually modify our Jacobian to have our Jacobian values. So run through the array. And we want the formula for the Jacobian, so we want to do f of our x values, which is, x0. And we want to subtract our f of our x plus h values, which is f of x that we just made. And then we want to divide by h. Divide by h. And actually, I already made, we want to do, it's f of our x plus h values minus our f of x values. And I already made this function up in the, I already made our just f of x values up above, right here. So I already have that one made. Alright, there we go. So now, tell it what element to modify. And that's what's actually doing the Jacobian. I need to return it.
Oh, it's okay.
So we're exiting the loop, and now in the inner function, I will return our array that we made. And then in our outer function, I want to return the inner function. So I'll run that. And now, like I said, I can feed this series of functions my curve function. So I'll just say, and I want to store it as a variable, so we'll say jack1 is equal to getJack, which is my outer function, and I want to feed that a function, which is going to be my curve function. The only thing I want to change in this in my curve function at this point is t. I want my r and mg to be the same, so we'll do this with a lambda variable. So we'll say lambda t, and then feed it curve at t, and then r, which is equal to the global r I made, and mz equal to the global mz that I made. And now we can look at the Jacobian at the different points. So we'll say, we'll just look at 0, and then I can compare this to Jax's automatic differentiation function. So not interpret 1 as a data type. Let's see. Oh, okay. Yeah. When I use the zeros, I have to actually feed it the right size.
Thank you very much.
Another error. Let's see. Built-in function or method object does not support. Function. Alright, there we go. I forgot copy was a function, so I had to close those brackets after it. Alright, so like I said, we now have our jack1 variable, which we can look at the Jacobian at different points, and it tells us the value, so 0, pretty much 3, and 0.4. And if I want to compare that to the automatic differentiation that Jax has, we'll do jack2 just to compare Jax.Jacobian. And we want to do the same function, our curve function. And we'll look at the same points, make sure they work the same. So jack2 at 0. And we get 0, 3, and 0.4. So it looks good. Alright, thank you.